Every single day, billions of people around the world reach for toilet paper without giving it a second thought. It's one of those products we absolutely take for granted, sitting there on the roll in our bathrooms, ready whenever we need it. But have you ever stopped to wonder about the incredible journey that simple sheet of paper takes before it reaches your home? The process is far more fascinating and complex than you could possibly imagine. Toilet paper manufacturing is actually a marvel of modern engineering and industrial precision. What starts as massive logs from carefully selected forests ends up as the soft, absorbent product we use every day. The transformation involves cutting-edge technology, chemistry, massive machinery, and surprisingly intricate processes that most people never see or think about. The industry itself is absolutely enormous. We're talking about a global market worth over $30 billion annually. In the United States alone, the average person uses approximately 100 rolls of toilet paper every single year. That's nearly 3 billion rolls annually just in one country. When you multiply that across the entire planet, the numbers become staggering. What makes this even more interesting is that toilet paper as we know it is actually a relatively recent invention. Before the late 1800s, people used everything from leaves and corn cobs to pages from catalogs and newspapers. The first commercially available toilet paper wasn't produced until 1857, and it wasn't until the early 1900s that it became soft and widely available. Today's toilet paper manufacturing process begins in the forest, where specific types of trees are carefully selected and harvested. The wood used typically comes from fast-growing softwood trees like pine, spruce, and fir. These trees are chosen because their long fibers create stronger, more absorbent paper. Sustainable forestry practices have become increasingly important, with many manufacturers now planting more trees than they harvest. The journey from tree to toilet paper starts at the pulp mill, and this is where things get really interesting. When the massive logs arrive at the facility, they're first stripped of their bark using huge industrial debarking drums. These rotating cylinders tumble the logs against each other, causing the bark to fall away. The bark isn't wasted though. It's often used as fuel to power the mill itself or processed into mulch for gardening. Once debarked, the logs are cut into small chips about the size of your thumb. This chipping process is crucial because it creates uniform pieces that will break down consistently during the next stages. The wood chips are then sorted to remove any that are too large or too small, ensuring consistency in the final product. Now comes one of the most critical steps, turning those wood chips into pulp. There are two main methods used in the industry: mechanical pulping and chemical pulping. Mechanical pulping involves grinding the wood chips against rotating stones while spraying them with water. This method preserves most of the wood's components, but produces a weaker, less refined pulp that's typically used for newspapers and lower quality paper products. For toilet paper, manufacturers primarily use chemical pulping, specifically a process called the Kraft process. The wood chips are cooked in a massive pressure vessel called a digester, with a mixture of chemicals, primarily sodium hydroxide and sodium sulfide, at high temperatures reaching up to 170 degrees Celsius. This chemical bath breaks down the lignin, which is the natural glue holding the wood fibers together. The cooking process takes several hours, and the result is a brown pulp that contains separated cellulose fibers. The spent cooking chemicals, called black liquor, are recovered and recycled in an impressive closed-loop system. This sustainability aspect is crucial for modern mills, as it significantly reduces both chemical costs and environmental impact. After the pulping process, the brown pulp needs to be cleaned and refined. It goes through multiple washing stages where it's diluted with water and passed through screens that remove any remaining impurities like bark fragments or incompletely cooked chips. The pulp at this stage looks like a thick brown soup with the consistency of oatmeal. Next comes bleaching, which is essential for creating the white toilet paper most consumers prefer. Modern bleaching processes have evolved significantly from the chlorine-based methods used decades ago. Today, most manufacturers use oxygen, hydrogen peroxide, and ozone in what's called ECF, or elemental chlorine-free bleaching. Some premium brands use TCF or totally chlorine-free processes, which rely entirely on oxygen-based compounds. The bleaching happens in stages, with the pulp moving through multiple towers, where different bleaching agents are applied at specific temperatures and pH levels. Between each stage, the pulp is washed to remove dissolved lignin and other compounds. This multi-stage process gradually whitens the fibers without damaging them, which is crucial for maintaining softness and strength. Once bleached to the desired brightness, the pulp is refined further to develop the right characteristics for toilet paper. This involves passing the fiber slurry through refiners, machines with rotating discs that have intricate patterns of bars and grooves. As the pulp passes between these discs, the cellulose fibers are slightly frayed and fibrillated, which increases their surface area and their ability to bond with each other. The refining process is an art as much as a science. Too little refining and the paper will be weak and rough. Too much refining and it becomes dense and less absorbent. Experienced papermakers adjust the refining based on the specific characteristics they want in the final product, whether it's ultra-soft premium toilet paper or strong economical varieties. Now we reach the paper-making machine itself, and this is where the magic really happens. The refined pulp, now diluted to about 99% water and only 1% fiber, is fed onto a moving wire mesh screen called the Fourdrinier. This screen can be incredibly wide, sometimes over 20 feet, and moves at speeds that would absolutely blow your mind, often exceeding 60 miles per hour. As the watery pulp hits the moving screen, water immediately starts draining through the mesh, and the fibers begin to interlock and form a mat. The machine is slightly vibrated, which helps orient the fibers and improve the paper's strength. By the time the forming pulp reaches the end of the wire section, it's already starting to look like paper, though it's still very wet and fragile. The wet paper web then moves to the press section, where it passes between massive rollers that squeeze out even more water. These press rollers can exert tremendous pressure. We're talking thousands of pounds per linear inch. The paper emerges from this section with its water content reduced from around 90% down to about 60%. Next comes the drying section, which consists of dozens of steam-heated cylinders arranged in 2 tiers. The paper snakes back and forth over and under these heated drums, which are maintained at temperatures around 130 degrees Celsius. As the paper travels over these cylinders, the remaining water evaporates and the fibers continue to bond together, creating a strong, cohesive sheet. For toilet paper specifically, there's an additional step that makes it soft and fluffy, a process called creeping. After the paper is mostly dry, it's pressed against a large heated cylinder called a Yankee dryer. A blade then scrapes the paper off this cylinder at just the right angle, creating thousands of tiny folds and creases in the sheet. This creeping process is what gives toilet paper its characteristic softness, bulk, and stretchability. The creeping process is absolutely crucial to creating toilet paper that people actually want to use. Without it, you'd essentially have tissue paper that's stiff and uncomfortable. The crepe pattern creates tiny pockets of air throughout the sheet, giving it a cushiony feel and allowing it to be more absorbent while using less actual fiber. Modern manufacturers have perfected the creeping process to an incredible degree. They carefully control the moisture content of the paper as it hits the Yankee dryer, the temperature of the cylinder, the angle and sharpness of the creeping blade, and the speed at which everything operates. Even tiny adjustments to these parameters can dramatically affect the final product's softness and strength. Some premium toilet papers go through additional processes to enhance softness. They might be sprayed with lotions or conditioners like aloe or vitamin E. Others use a process called embossing, where the paper is passed through rollers with raised patterns that create decorative designs while also increasing the paper's bulk and perceived softness. After the paper is fully dried and creeped, it's wound onto massive parent rolls. These jumbo rolls can be 10 feet wide and weigh several tons. They're truly impressive to see in person. These enormous cylinders of paper towering over the workers in the factory. Each parent roll contains enough paper to make thousands of individual toilet paper rolls. The parent rolls are then transported to the converting area, where they're transformed into the familiar product you buy at the store.